Hello, I'm Anna Mackay and this video is on the area under a curve part 2 of 2. So two different examples here. So our first question is we need to use the rules of integration to find the value of k if the shaded area is equal to 9 units. So the area under the curve, we know that the answer is going to be 9 for this function here, but we don't know what that number is there. Now I'm all for using your graphics calculators to help you find out the answer, but the point is you don't know what the upper bound is, so you couldn't put that into your calculator. So you must know how to solve these by hand. So we write out an integral for this function. So we have the integral of x squared take 2x plus 3 dx between what points? Well, as we can see, we've got the intersection here, that x equals 0 and k. So 0 to k. And this time around we know that the answer will be 9. 9 units squared is the area. So let's integrate that and see what we get. So rules of integration, x cubed on 3, we're going to get x to the power of 2 on 2, so those 2's will cancel, ending up with x squared plus 3x using square brackets between k and 0, and that's equal to 9. So now we can substitute in k and 0 and see if that helps us solve things. Now I probably shouldn't put equals here because I've already got another one on that row, so if you like to put something, put therefore. Round brackets now, we have k cubed on 3, take k squared plus 3k, take away, where we're subbing in 0 now, and all of those will end up being 0, so we'll just write that is equal to 9. And now we need to solve for k. So we're going to rearrange where we make everything on the right hand side equal to 0, and I'm going to multiply through by 3 as well. So k cubed take 3k squared plus 9k, it'll end up being take 9, and so take 27 is equal to 0. Now, how do we solve for k here? It's absolutely fine at this point to use your graphics calculator. So we're going to put this in. I'll just show you how. So we're in the equation menu. I've got the function written here. So we want to go into polynomial. So f2, degree of 3, and putting in our coefficients of k, 1, -3, 9, -27, solving, and it's saying 3. So that will be our k value. So we'll go back to our question. Mine will have disappeared, but that's okay. And we'll write that our final answer is therefore k is equal to 3. So that's how we finish that off. Second one, a trig question. Find the area enclosed by one arch of the curve y equals cos 2x and the x-axis. So you must use your calculators to see what this looks like. So into our graph menu, we have y equals cos of 2x. So start with a trig window and let's see what we're after. All right, so we only want one arch, one full arc. So let's restrict our window. Let's have x going from 0. And because we really only want one here, I'm going to stop my graph here, which is the equivalent of 2 pi. So make 2 pi maximum for x. Okay, so we're going to have a think about this here so that we can go back and work it out algebraically. So one arc of the curve is there. We need to know what these points are where it cuts through the x-axis. So start thinking about that. Here is 3.1415, so that's pi. So the period of this cos function has a period of pi, so it's going to repeat every time. So logically, if there's pi, that's half of pi, pi on 2. So you can see what that one's going to be, and the next one again. But when we work out the x-intercepts, the first one that's going to give us is here. So that'll come in handy a bit later. Let's find out, first of all, what these 2 points are. So we need to find, solve the roots. So it gives us the first one there, the 0.78, arrow across, 2.356, we'll remember that. Next one across, 3.927. So when you're doing these questions, write down those numbers that you get as a means of checking when you're dealing with pi. And the other thing, let's work out the area between these 2 points. Now, but then I'd have to tell you what those points are. So perhaps you could come back and check that at the end. So now we're going to go back to do some calculations. So remember 3.92 and a 2.35. So here we go. Loading up. So we need to integrate this. No, before we do that, we need to find out algebraically where the cos function, so we've got cos of 2x is equal to 0. So that's those x-intercepts. So essentially what we're doing is you can use the run mode of your calculator. You're essentially working that out. When is the inverse of cos 0? So what are those values? Now, feel free to just use your calculator, and the first one it will tell you is pi on 2. But we know that there's clearly more than one. You can also use your unit circle to work that out. So when is, well, we've got pi on 2 as one of them. Pi on 2 is 90 degrees, and that's going to repeat again down here at 3 pi on 2. So that's when cos is equal to 0. So that's our x value here and here. So, oops, sorry, I should have written pi on 2 is the first one. So they're the two values that we use over here, because that's when cos is equal to 0. So we write pi on 2, comma 3 pi on 2, and then we solve for x. So we get x is equal to, where we divide each of these through by 2. So we're going to get pi on 4 and 3 pi on 4. Now, here's where you need to know what this graph looks like to be able to solve this properly. This number here, if you put into your run mode, comes out to be about 0.785. Now, that was not one of the first numbers that we needed. This one is, that's an arrow, 2.356. So that's our first point. You may remember that the first x-intercept that happened on that graph, if I just draw a little picture for you here. So remember we had here, very roughly, here is pi. That number there is this number here. That's pi on 4. 3 pi on 4 is that number there, the 2.356. So the ones we're interested in are here, the 3 pi on 4, and here. So what is that in terms of pi? It's a multiple of this pi on 4. And you need to now know that the period for this cos 2x function is pi. So if you take pi on 4 and add on pi to it, one period, you will get the repeating equivalent of that point. So pi on 4 plus pi is 5 pi on 4. So 5 pi on 4 is this one, and 3 pi on 4 is that point. So they are our lower and upper bounds that we now need to integrate this function. So let's do that. Let's write our integral for cos 2x dx between those bounds. We had 3 pi on 4 and 5 pi on 4. So integrating, we get the integral of cos is sine of 2x, but remember we have to go 1 on 2 out the front because of that 2x there, and putting our upper bound 5 pi on 4 and our lower bound 3 pi on 4. Substituting in those values, round brackets now, a half sine of, I'm going to have 2 multiplied by 5 pi on 4, which I'm just going to write down is 5 pi on 2, and then taking away a half sine, and this time around substituting in 3 pi on 4, multiplying that by 2, so we're going to get 3 pi on 2. So now we need to work out what these values are. Again, feel free to use your unit circle if you're confident with that, or in your run mode if it's in radians. feel free to put in sine 5 pi on 2. You'll need to recognise the decimals if they're decimals, recognising if it's 1 on root 2 or those types of things. But this one turns out to be a nice one. So we have a half times by 1. So sine of 5 pi on 2 is 1. Take away a half of -1 this time round. And that works out to be a half plus a half. And so we have an area of 1. So meant to mention in previous videos, the area is 1 unit squared. Well, unit in that case because it's singular. Unit squared. Okay, that's the end of this video. If you liked it, give it a thumbs up, subscribe to the channel, and the next video in this series is the area between two functions. Thank you.